Now we are going to see another assignment problem. Okay. This is a modification to the basic assignment problem. Here we have a school district that has to cover busing routes. So it has 8 busing routes, and they want to give contracts out to bus companies to cover these 8 routes. So they have called out for bids, and they have received bids from 6 companies. Now we need to assign these routes to the companies. So each route should be assigned to only one company. And each company has given bids not for all the routes, but the routes that they wanted to bid for. So like company 1 has bid for routes 2, 3, 4, and 6 only. Okay. And similarly the rest of the companies. So if the company did not bid, then you cannot assign a route to that company. So route 1 can be assigned to only company 2, 5, or 6. Our objective is to make the assignments in such a way that we want to minimize the total cost of covering all the routes. And the constraint here is, of course, we have to assign each route to exactly one company, and we also here have a requirement that exactly one company must be assigned to each. We are also assuming here that a company can be assigned at most 2 routes. So company can be assigned 2 routes, but each route can be assigned to only one company. So let's look at the data in Excel. Okay. So now what we need to do, so here is the input data. Maximum routes allowed per company is 2, so that's an input. Now we're going to set this up like a flow model. So wherever there is a bid, now we're going to enter the origin and destination. So here origin would be the company, destination would be the bus route. Okay. And then enter the cost here. So we have 1 with route 2. So 1 and 1 is not, there is no bid for that. So we have 1 to 1 to 3 and 1 to 4 and 1 to 6. So we have 1 to 2, 1 to 3, 1 to 4, and 1 to 6. And the corresponding costs are 8200, 7800, 5400, and 3900. 8200, 7800, 5400, and 3900. Okay. Now the second company. Second company has bid, so we have 2 to 1, 2 to 2, 2 to 4, 2 to 6, and 2 to 7. So we have 2 and 1, then 2 to 2, 2 to 4, and 2 to 6. And now we have to enter the costs and keep going until all the routes, the route number 6 is also entered. Okay. Now I have already done all of that in the next sheet. So let's jump to the next sheet. And here are all the destination origins and destinations in the cost. So let's go ahead and color code these. So the cost is given. Okay. Now the flow is what we have to determine. So that's our changing cell. So let's give names for these. Okay. Now maximum allowed, so let's give a name here. Maximum allowed is that. So now copy that. Okay. Now required is 1, so we have to assign each route to exactly Control C, Control V. So these are once again given values. Okay. So now we're going to use the SUMIF function for routes assigned. SUMIF origin is the range, criteria is the company, and we want to sum the flow. And that should be less than or equal to the maximum allowed. We copy that. Now here again we use SUMIF. Now we use the destination as the range, and the route number is the criterion, and we will again sum the flow, and that should be equal to 1. So let's copy that. Okay, let's give names for these 4 ranges. So remember to do control click and drag, so that way you will be able to highlight non-contiguous ranges. And then the cost to minimize is sum product of cost and flow. And that's what we want to minimize, so that's our objective function. Let's give a name here. Okay, now we can run solver. We want to minimize that. We want flow to be the changing cells, and then the constraints are we want routes assigned less than or equal to maximum allowed, and then companies assigned is equal to required. Okay, now non-negative and simplex LP and solve. Okay, and make sure that these are all ones and not 0.5 or something. Yeah, and here is the total cost. Now remember, we did not specify that the flow must be 0 or 1, and automatically you get that because of the structure of the problem. Okay, later in the next chapter we're going to look at problems where we want 0 or 1, where we have to request 0 or 1, otherwise you will have values that are decimal values like 0.3 or 0.78 or something like that. And here for assignment problems, this is a property that the changing cells will always be either 0 or 1 because of these requirements that we have. We can now run a solver table and change the maximum routes allowed per company, and then see how the total cost will change. So let's go ahead and do that. Solver table. We want one-way table, and the input cell is this. And let's assume that we want to go from allowed is 1 all the way up to 7. Okay, there are totally 8 routes, but up to 7 in increments of 1. And we want to look at the total cost and see how that changes. And you see, if you allow only 1 route per company, then There are only 6 companies, so only 6 routes will get assigned. 2 routes will not get assigned. So that's why that's not feasible. And if you have 2 routes allowed as the maximum, and then the rates go down as you allow more and more routes to be assigned to different companies, but the difference in cost is not that much. So if you have more companies, then you have more flexibility in operations.